Now we're going to learn the section 1D. It's called analyzing argument. What happened, Sky? It's my dog. She's not very happy now. Okay, analyzing argument. First of all, we're going to learn two concepts. One is called inductive. Inductive. What? Argument. And the other one is called deductive. Ew. That's a funny sound. Okay. Okay. The inductive argument is from specific to general. And this one is from general to specific. What does that mean? Let me give you two examples, okay? Well, first of all, we talk about an inductive argument. Okay, think about this, the premises. Okay, Emily is a good student. Alexa is a good student. Did you notice that all those are specific case, right? And Ashlyn is a good student. And there are all those are three students in my class. And of course, I got more than 3 students. Now I get a conclusion. Everyone in my class is a good student. You like to hear that, right? I think that's true too. All right, now see, this is from specific to general. Specific to general. Specific. Emily is a good student. Alex is a good student. Ashlyn is a good student. The general, the conclusion is by the general. Everyone in my class is a good student. What do you think? What do you think from the specific premises to the general conclusion? Well, this inductive argument cannot prove its conclusion is true. Okay? It can be either strong or weak. Okay? It doesn't really mean it's true, but it can be either strong or weak. For example, Emily is a good student. Alex is good. Ashlyn is good. I keep calling every student's name, not the whole class, but maybe like 2/3 of the class, or maybe like 80% students in my class. Each one is a good student. Therefore, my conclusion is everyone in my class is a good student. This is a strong argument. Strong. It's a strong argument. Okay. But sometimes if I just give you this 3, and in this semester, for example, I have 5,000 students. Well, you give me this 3, then the conclusion that everyone in my class is a good student, it's a pretty weak. It's a pretty weak argument. Okay, because the conclusion is not well supported by the premises. Okay, the conclusion may still be true. Even I just said there's 3 good student. This is good student. 1, 2, 3 students. They are good students. And even I have like let's say 5,000 students in my class. I don't know. I have that huge class. Everyone is in my class. Everyone in my class is a good student. This is a weak argument, but it might be true. It still could be true. So strong or weak has nothing to do with true or false. Okay. How can you tell whether this argument is a strong inductive argument? First of all, you look at the sample size, isn't it? 1, 2, 3, only 3. This is the sample size. Sample size is 3. Is this a sample size? Is this sample large? Well, it depends. If my class only has 5 students, then this is pretty good sample. If I have like a 5,000 students, then 3 is not a good sample. So this sample might not represent the general case. Okay. So get the idea about inductive argument? Inductive argument, A is good, B is good, C is good. Therefore, all the letters are good. From specific to general, and that conclusion could be true, could be right, could be wrong, which we don't know. Logically, when we just only talk about this argument, it could be either a strong argument, strong inductive, or it could be a weak. Okay, it depends on the sample size, or it depends on whether the sample is a good representative of the whole population. All right, now we're going to talk about a deductive argument. Deductive argument means from a general case to a specific case. Okay, so here's the premise. Everyone in my class is a good student. Okay, and another one. Emily is in my class. Conclusion. Emily is a good student. What do you think? From general to specific. Okay? From general to specific. This is called a deductive argument. Deductive argument. Now, for the deductive argument, we can say whether this is valid or whether this is sound. What does that mean? Valid. Valid means logically correct. Is this logically correct? Everybody is a good student. Everybody in my class is a good student. Emily is in my class. Therefore, Emily is a good student. So if I ask you to show the Venn diagram, this is Emily. Okay. This is Emily. And that's my class. Oh, yeah. Okay. That's my class, and Emily is one of the students in my class. And here is a greater set. It's a bigger set. All those are good students. So Emily is in my class, and everybody in my class is a good student, which means my class, the students in my class, this set, it's a subset of good students. So Emily, I can think that's also a subset. It has only one element. Emily is there. So Emily is an element in this subset of the big set. Therefore, Emily should be a member or an element of a good student. Therefore, Emily is a good student. This is true. Logically correct. This is a valid. Okay, this is a valid deductive argument. Valid means logically true. If a statement is valid plus true, means correct, then that become a sound. It become a sound argument. Okay, what does that mean? That means here's true, this is true. Emily is a good student, and that's a sound statement or sound argument. But this premise might not be true. Everybody in my class is a good student. First of all, this might not be true, because I do have some students never showed up in class, never turning homework, and I cannot tell that they studied hard. So I cannot say they are a good student. So even I put things here, might not be true. Emily is in my class. Emily is a good student. We don't know. So it's a valid but not sound. We don't know yet. Okay, so valid plus true becomes sound. All right, now let me ask you next. I need to give you some more examples, and then you tell me whether it's valid or sound for the deductive. Remember, deductive means from general to specific. Okay, premises. All fish live in water. Okay. Whales are not fish. Okay, conclusion. Whales do not live in water. What do you think? I really know that this is not right. We know whales. We know they live in water. So what happened if they said all fish live in water? The second premise is whales are not fish. Therefore, whales do not live in water. So this is one example of deductive argument, but what do you think? It is valid. It is valid. It's logically you can get to this conclusion. Okay, all fish live in water. So here's a fish. All fish live in water. Right? What about the whales? We know whales are here. Whales are not fish. Whales definitely, these two they disjoin, right? These two sets are disjoint. So whales are not fish, and of course there's some other things live in water. They're not fish. They're not whales. But anyway, whales are not fish. That you cannot get the conclusion that whales do not live in water. So this is invalid. Okay. Now next one. Did you notice that when I give you these two premises and then I give you the conclusion, this is a deductive argument? If I ask you whether this is valid or not, you can use a Venn diagram to show that, right? Okay, so now next one. Okay. Again, all 20th century U.S. presidents were men. Another one, John Kennedy, JFK, was a man. Conclusion. JF, JFK. JFK was a 20th century U.S. president. We know he was. Is this true? Is this valid or invalid? What do you think? This argument, all 20th century presidents were men. Okay, so this is the 20th century U.S. presidents, men, right? Every single president was a man. And JFK was a man. So JFK is inside this big circle. And the conclusion says, oh, he was a 20th century US president. This is invalid. You cannot get that conclusion because if you change this JFK to be Michael Jordan, Michael Jordan was a man, but Michael Jordan was not a 20th century US president. So Michael Jordan case, in that case, this is definitely not true. So you can tell that this argument is invalid. Okay. However, is this conclusion true? True. All 20th century US presidents are men. If someone is a 20th century US president, then he must be a man. So if then, right? So this sentence give you if then. Let me give you another example here. Okay, people live in Chicago like windy days. Or if a person lives in Chicago, then he likes, he or she likes windy days. It's the same thing, okay? That's what I just rewrite that as the if then sentence. Another one. Julia lives in Chicago. Julia lives in Chicago. Conclusion. Julia likes windy days. What do you think? Is this valid? We can say if somebody lives in Chicago, so here is the set of people who live in Chicago. Chicago. Likes or like windy days. Okay, so this Venn diagram shows everybody lives in Chicago likes windy days, right? So because people live in Chicago is a subset of this big set. The bigger set is all the people who like windy days. Now, Julia lives in Chicago, so Julia lives here. Julia lives in Chicago. Julia is a element in this little subset, so she must be an element of the bigger subset. So this is a valid. This is a valid deductive argument. Okay, so that gives you like a lot of you can give a lot of examples and to tell me whether this is a valid or not. Okay, and then I will talk about 4 basic conditional argument. Conditional. Which is like the if P, then Q, that type of thing. Okay, so if P, then Q. Given if P, then Q. Now, P is true. Therefore, Q. P is true, therefore Q is true. If P, then Q. If someone lives in Chicago, then he or she loves windy days. Okay. If P is true, Julia lives in Chicago. Remember, P is living in Chicago. Q is true. Q likes windy days. Okay, so this one is called P is true, then Q is true. Now P is true. So this is the it's called affirming the hypothesis. Okay, so this is a valid. Just the windy day example. Okay, now if P, then Q. P, if P is true, then Q is true. Then that is a valid statement, a valid argument. Okay, the next one. If Q is true, then P is true. I just say use this as equal or is the same thing. Okay, think about that. If P, then Q. If someone lives in Chicago, then this person likes windy days. Now, if Q is true, right now somebody likes windy days, then he must live in Chicago. Is that right? Of course not. Somebody likes windy days doesn't really mean that he lives in Chicago, so this is invalid. Okay. Did you see this? You said if P is true. So P here is called the hypothesis. Hypothesis. Okay. And this is called a conclusion. Okay, it's too small. Okay, so this one is the affirming. When you try just to affirming the hypothesis, you get a valid argument. Okay, but if you want just to affirming the conclusion, you will get an invalid argument. All right, now I can continue because I said 4 basic, so there are 2 more. If P not true, then Q not true. If someone doesn't live in Chicago, then he or she does not like windy days. This is also invalid. Because I do have people who do not live in Chicago, but they still like windy days. So this is called, because if P not true, so you are denying hypothesis. If P not true, so this is not right. So you're going to say, this is denying the hypothesis. Okay. That will give you an invalid statement. Okay, now last one. Okay, so 4 basic one. The last one. If Q not true, then P not true. Okay, so this is very tricky. If someone doesn't like windy days, then he or she does not live in Chicago. If someone doesn't like windy days, means somebody is outside the big circle, someone is flying or staying outside, then he must be outside this smaller circle. True. So that's good. It's a valid argument. And you said if Q not true, so you are denying the conclusion. Okay, let me say that. If you are affirming the hypothesis or denying the conclusion, you get a valid deductive argument. If you're affirming the conclusion or denying the hypothesis, you get an invalid deductive argument. Okay, you should be able to make a table by yourself, but I can give you a lot examples, and then I keep using this. Okay, so let me give you the example here. P. If you like the book, then you love the movie because this movie is made from this book. Okay, Q. You did not like the book. Conclusion. You did not love the movie. What do you think? Is this a valid or invalid deductive argument? Now, you like the book, then you love the movie. So if you like the book, if you like the book, you must love the movie. right? Everybody likes the book, loves the movie. You did not like the book, which means you're not here, so you're outside. And the conclusion, they tell you that you did not love the movie. That's invalid. Because you do not like the book, but they still love the movie. Or you do not like book, you don't love the movie, right? So this is an invalid statement. And what you're doing is you did not like the book. If you like the book, this is P, this is Q. I'm so sorry, I shouldn't do it here. So you did not like the book. If not P, condition. You're denying the hypothesis. You're denying the hypothesis. So that's invalid. Okay. See, if P not true, if you don't like the book, then you don't love the movie. This is invalid, denying the hypothesis. Okay. Next one. Next example. If you say your wish out loud, then it won't come true. If then. Okay. Now, that's one of the premises. And another one, your wish did not, did come true. Your wish did come true. And my conclusion is, therefore, you did not say your wish out loud. If you say your wish out loud, then it won't come true. So loud. If you say loud, then not come true. Right? So you say it out loud, and then it's not going to come true. Of course, sometimes when you didn't say that out loud, it will not come true. Now, your wish did not come true. So if then, this is a hypothesis, this is a conclusion. Your wish did not come true. Did come true. So what you're doing is you're denying, because then this is a little tricky here. So it says it won't come true, but your wish did come true. So you're denying the conclusion. You're denying the conclusion, which is going to be a valid statement. So your wish did not come true. Your wish did not come true. I keep saying did not. Your wish did come true. So you are outside this big circle. They said that therefore you did not say your wish out loud. So you must be outside this little circle, which is valid. Okay, so hypothesis, conclusion, and you're denying the conclusion. If you're denying the conclusion, it's a valid deductive argument. Okay, now what do we learn in this session is we learned inductive, deductive. Inductive is from specific to general, and it could be either weak or strong. And the deductive is from general to specific. Okay, so it could be either valid or not valid. All right, now you have to be able to identify the four basic conditional arguments: affirming hypothesis, affirming conclusion, denying hypothesis, and denying conclusion. So those are the four basic conditional arguments, and you should be able to identify. So there are plenty practice. I hope you can just go ahead and do the homework. I think you're going to see more examples. Or if you like to read the book, you can read the book. And if you want to come to talk to me in my next class, then you're welcome to do so. Okay, thank you.